What's up? I'm Vin, and I'm going through the June 2024 Algebra 1 Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. So we're starting off with the part 1 questions, the multiple choice, and every question here is worth 2 credits. For question 1, we have a ball was launched into the air and its height above the ground was recorded each second as shown in the table below. Based on these data, which statement is a valid conclusion? So for something like this, we just have to go through the answer choices one by one. But what I'm imagining for something like this is the path that the ball follows as it was launched. So here, if we look at the table of values, at time 0, the height of the ball is at 11 feet. Okay, so this is going to represent the time and the height of the ball. And the way that these values are showing up in the table, we could see the repeating values here, that this ball is going to take on a parabolic path. Okay, it's going to form a parabola as it goes. Okay, so we're just looking here like this, and at least that's what I'm imagining, and then the ball hits the ground eventually. So now I go to the answer choices. The ball lands on the ground at 4 seconds. Well, notice at 4 seconds, so if I put 4 over here, that the ball is 11 feet in the air. So that wouldn't make sense because the ground would represent when the height is equal to 0, and at t equals 4, the height is 11. So 1 is not the answer. 2, the ball reaches a maximum height of 11 feet. Well, notice that as time goes on after the launch, the height of the ball increases, and it appears that the maximum height of the ball is 75 because this is the time where the ball makes the turn here, and it goes from a height of, let's say, 59 to 75, but then it starts to drop back down to 59, then 11. So the maximum height is looking like 75, which happens at 2 seconds, not what's happening here in choice 2. So 4 is looking good, but I'm just going to eliminate this choice as well here to see why is this no good. So the ball was launched from a height of 0 feet. Well, the ball was launched is talking about time t equals 0. And at time 0, the ball is at a height of 11 feet. So it was launched from a height of 11 feet, not 0 feet. So that's why 3 is no good. 4 is definitely our answer. Question 2, a tour bus can seat at most 48 passengers. An adult ticket costs $18 and a child ticket costs $12. The bus company must collect at least $650 to make a profit. If A represents the number of adult tickets sold and C represents the number of child tickets sold, which system of inequalities models this situation if they make a profit? So one thing I noticed right away about all the answer choices is that they all have A plus C and they have 18A plus 12C. So 18A represents how much money the bus company makes from selling adult tickets, because the adult tickets are $18 and A is representing the number of adult tickets sold. So that's what the 18A represents. And then 12C represents the amount of money made from selling the kid tickets. The kid tickets are $12 and C represents the number of child tickets sold. So this in total, 18A plus 12C represents the money collected. And now let's reread the important part of the question. They told us the bus company must collect at least $650 to make a profit. So if you have to reread that a few times so that you set this up correctly, if the bus company has to collect at least $650, that means they need to collect greater than or equal to $650. All right, if you just think about this carefully, if I put a less than sign here, that wouldn't be good because if they make less than $650, then they're not going to make their profit. So the money collected has to be greater than or equal to $650. The reason why we could have equal to is the word at least. If they said the bus company must collect more than $650, then it would be just greater than. Okay, so I could get rid of these two choices here where the equal to is not included. I mean, we could even get rid of choice 4 as well because there's a less than or equal to, and choice 2 has to be it. But let's see, why is it A plus C is less than or equal to 48? Well, they told us that the bus can seat at most 48 passengers. Okay, so that means the number of adults plus the number of kids has to stay less than or equal to 48 because if it was over 48, there wouldn't be enough space on the bus. So choice 2 is our answer. Question 3, which equation is always true? And for this one, we have to know our properties of exponents. So when I have something like a to the b times a to the c, I multiply two exponents with the same base, I keep the base the same, and I add the exponents together. So looking at choice 1 is already looking good because if I want to do x to the second times x to the third, I'm using this property of exponents. I'm doing x to the 2 plus 3, which is going to make x to the 5th. But why are the other answer choices no good? Well, this one here, choice 2, would work out to 3 to the x plus 2 power. It would not work out to 9 to the 2x. So that's why this one here is not true. It's not always true. I mean, maybe we could find out a random value of x that would make it work, but this is not always going to be true. And now when I look at 3, if I square something and then I just put a minus sign in front of it, these are going to be opposites. This would be true only when z is equal to 0, but for any other numbers, this is not true. We want the one that is always true, not sometimes true. And then this one here, this is using the property incorrectly. This would always be true if they let 7a times 7, if they let 7 to the a times 7 to the b equal 7 to the a plus b, then it would always be true. But that's not the case here. This one is out. This 7 to the ab power happens when you raise a power to a power like this. Then I could say 7 to the ab, but that's not what happened here. So choice 1 is our answer. Question 4, the expression here is equivalent to, and we have these 4 answer choices. So this question I'll do 2 ways. I'll do this algebraically, and then I'll show a nice calculator trick. So what I'm going to do first for the algebra method is I'm going to distribute the negative 2. So I'm going to multiply all of the terms in this trinomial in the parentheses by negative 2. So we have negative 2 times x squared is negative 2x squared. Then we have negative 2 times negative 2x is positive 4x. And then we have negative 2 times positive 1 is negative 2. And I'm adding this trinomial, but what I'm going to do is I'm going to write it underneath, and I'm going to line up the like terms. So 3x squared belongs under negative 2x squared. These are like terms. And then plus 3x is going to go under the 4x, and then minus 5 is going to go with the minus 2. And we're adding these together. This is a lot like if I were to add something like 123 plus 456. If we went back to elementary school math, we would line these up vertically. I would write 1, 2, 3, and 4, 5, 6 underneath and add them. And I would make sure to add the ones place, the tens place, and then the hundreds place. Okay, so if we had to work this out, this would be if we were doing the old elementary school math. And now it's the same idea, it's just a little bit more complicated because now we have x's. So I'm doing negative 2 plus negative 5 is negative 7. If I do 4 plus 3, that's 7, but I just have to tack on the x. And then I have negative 2 plus 3 is positive 1. And now the x squared just comes down. And remember, this was a positive 7x. So I'm going to put a plus here. And now I just look for the answer. I have x squared plus 7x minus 7. This matches choice 4. Now, let's say this algebra is a little bit intimidating. What you could also do is you could type in the original expression here. So I have negative 2. And then in parentheses, I have x squared minus 2x. And then I have plus 1. And then I close the parentheses. I have plus. And then we have 3x squared plus 3x and then minus 5. So I could type in the original expression, and then I could type in the answers one by one. But of course, the correct answer is choice 4. So if you were to start at 1 and keep typing these in, it would take you until 4 to get something that matches. So when I write in the correct answer, x squared plus 7x and then minus 7, you're going to see that when I press graph, both of these graphs are going to completely overlap. So these two are definitely the match. If I type in one of the wrong answers, like let's say I type in choice 3, and instead of x squared plus 7x minus 7, I put a minus 4. Notice now when I graph the wrong answer, these two graphs do not completely overlap. So that would tell us 3 is not correct. So this is just a nice alternate approach. You could also just do this algebraically and then check your answer the way I just did. But either way, choice 4 is going to be our answer. Question 5, which sum is irrational? So for this one here, what I'm looking for is I'm looking for an irrational number out of one of these pieces in the sum. So looking at all of the answer choices, I could see one jumps out right away as the answer, which one is irrational. And where my head goes is perfect squares. So I'll do this no calculator first, and then I'll show how to do this with the calculator. So I'm looking at choice 2, and I see, oh, 4 is a perfect square. The square root of 4 is 2, and there's a minus sign in front, so that's just going to make minus 2. Plus 1/3, the square root of 900 is 30. So notice that I get nice whole numbers here. I do have this fraction over here, but fractions are rational. If you have a fraction where you have an integer on top and bottom, as long as there's not a 0 on bottom, you have a rational number. And when you add fractions and whole numbers with other fractions and whole numbers, you get something rational. So that's how I know 2 is rational. It is not irrational. And now for 3, this would work out to 1/2 times the square root of 25 is 5, and then plus 8. So notice I would have 5 over 2 plus 8. I have a whole number plus a fraction would be rational, not irrational. And then here, this would work out to, we would have 7 plus 3 times the square root of 121 is 11. And this would give me 7 plus 33. And a whole number plus a whole number is rational. So I can just think my way through this, or, we could just use the calculator. So for the calculator, I could start off with choice 1 by writing -2. Square root is second and then x squared. And then I have 12. And then I'm going to do plus the square root of 100. And what I'm doing here is I have this number is irrational because 12 is not a perfect square. 100 is rational because the square root of 100 is 10. So if I do 10 plus an irrational number, that's going to be something irrational. But see what it looks like here in the calculator. We have a decimal that goes on and on with no repeating pattern to it. So that's one way of seeing that choice 1 is irrational. If I type in one of the answers that was not our answer choice, the ones that were not irrational, the ones that were rational, like let's say choice 2, if I write in negative square root 4, and remember the negative is on the outside, so I have negative square root 4 plus 1/3. I'm going to press alpha y equals enter to pull up a blank fraction. This is just a nice way to type in a fraction in the TI-84 plus CE. And then I have the square root of 900. Notice when I do it this way, that I get a whole number. Okay, I get a whole number 8. So that's how I know 2 is not irrational. And you could do this for all the other answer choices. But if you want to trust your understanding of the concepts, you can just see, oh, wait a minute, this is the only non-perfect square. And that would tell me that this part is irrational, and the sum of an irrational and a rational number is irrational. Question 6, the solution to this equation is, and for this one, I'll do this 2 ways. I'll do the algebra, and then I'll do the calculator method. So first, if I'm doing the algebra, I'm going to start by subtracting 2 on both sides. And that's going to give us 4 times x minus 5 over 3 is equal to 14 minus 2 is 12. And then from here, what we could do is we can cross multiply. Okay, so I could do cross multiplying here. I have 4 times x minus 5 times 1 is just 4 times x minus 5 equals, and then I have 12 times 3 is 36. And now I can distribute here, but a nicer way to solve this would be to divide both sides by 4. Because this says 4 times x minus 5. So I could get rid of the times 4 by dividing by 4. And now I'll write the result over here. We have x minus 5 is equal to 36 divided by 4 is 9. And now I just add 5 to both sides. And that's going to give us, we're going to have x equals 14. So our solution here, the solution x is equal to 14. Choice 2 is our answer. But another thing we could do is just press math, hit up, and then numeric solver, option C. And equation 1 is the left side. So if I type in alpha y equals enter to pull up a blank fraction, now I could write 4 times x minus 5. I close the parentheses. I put my 3 in the denominator. I hit the right arrow to get out of the fraction. And originally it was this fraction plus 2. And now the right side of the equal sign goes by equation or expression 2 here. And then I press OK by pressing graph. And I press graph again to solve. And notice I get x equals 14. Okay, so this works for solving linear equations. You could also have just gone on the main screen and typed in the expression on the left, hitting alpha y equals enter, and just type in all of the answer choices one by one. Like let's say I do 4 times x, I plug in 15, and I do minus 5, and then 3 in the denominator. I hit the right arrow, and then plus 2. If I put in one of the wrong answers, and I'm going to do this, I'm going to press mode and change from fraction to decimal. So answers, I'm going to switch from auto to decimal. That way it just looks nicer. So here, I'll just do this one more time. And you see we get 15 and a third, which does not match 14. We need it to match 14. So now when I plug in 14 for x, this time around, see I get exactly 14. And I could plug in the other answer choices to see why those are wrong. So these are just a few ways you could use the calculator to get your answer, but either way, we're getting choice 2. Question 7, on an island, a rare breed of rabbit doubled its population each month for 2 years. Which type of function best models the increase in population at the end of 2 years? So for this one, what we could imagine here, if you just can't jump right to exponential growth, is just plug in some numbers. Let's say the rabbit population starts off at, I don't know, let's say 8 rabbits. and then it doubles each month. So then a month later, it would be at 16. So that would be, let's say, up this distance here. So at 16, that's where it would be a month later. And then this distance here, 16, we have to double 16 to get 32. So then I would jump way up here at 32. And then this will quickly get out of control. So let me just move this over a little bit so that it's definitely drawn a little bit more to scale. But if I plot this point and then I connect, I think it'll be more obvious here that this is going to be an exponential curve. Okay, so we could see that the next one is going up to 32. So if I start to connect these now, notice it's not forming a straight line. It's going to form an exponential curve. So that's why here it would be exponential growth. Linear growth would be if the same amount of rabbits are added to the population each month. But the fact that it's doubled tells us that it's increasing at an exponential rate. Okay, and it's not decay because the population is not dying off. The population is growing. So choice 3 is our answer. Question 8, what is the degree of the polynomial 2x minus x squared plus 4x to the third? So when we're looking for the degree of a polynomial, we're looking for the highest power of x that appears. Okay, so the highest power of x. And when I'm looking at this polynomial, they made it a little bit tricky that they put the powers out of order. We want this to be in standard form. So we want this in the form 4x to the third minus x squared plus 2x. We want the powers to be descending because then it's very easy to spot the degree. It's the term in the front. But just know if you're not careful, you might look for the first term and say, oh, x to the first, and choose something like choice 1. But no, we have to just be on the lookout here. We're looking for the highest power of x, and the highest power of x that appears is x to the third. So this is a third degree polynomial. Question 9, the zeros of the function f of x given here are, and we have these 4 answers to choose from. Well, when we're looking for the zeros, or we could also call this the roots, we are going to set each factor equal to 0 and solve. So the first factor is just x. And when I set x equal to 0, this will tell us that x equals 0 is one of the roots or zeros of the function. So that eliminates these 2 answer choices here. And now I'm going to set the second factor equal to 0. If I set x minus 5 equal to 0, this is true when x is equal to 5, which I get from just solving this simple equation. I add 5 to both sides, and this gives us x equals 5. So that means choice 1 is out. It definitely has to be choice 2 here. But where is the root of negative 2 coming from? That would come from setting 3x plus 6 equal to 0. So if I set 3x plus 6 equal to 0 and solve, I'm going to do minus 6 on both sides. And that's going to give us 3x equals minus 6. And then I divide both sides by 3. And here I have x equals negative 6 divided by 3 is negative 2. So there's the third root. We have roots of, well, let me just make that a little bit neater. We have a root at x equals 0, at x equals 5, and at x equals negative 2. So choice 2 is definitely our answer. If you want a visual of question 9, what you could do is go over to the y equals, and we'll clear everything out, and type in f of x. We could write it in factored form like this, and we'll see what the graph looks like. So I'm just typing in x times x minus 5, and then times 3x plus 6. So we press graph, and notice that the blue graph hits the x-axis at negative 2, at 0, and at 5, which matches what we have here for choice 2. Question 10, what is the y-intercept of the line that passes through the points negative 1, 5, and 2, negative 1? So for this question, I'll show how to do this algebraically, and then I'll show how to use the calculator. So if I'm doing this algebraically, first I'm going to label these points as x1, y1, and x2, y2. That way I could just plug into the slope formula. And the slope between 2 points, we could find using this formula here, y2 minus y1 over x2 minus x1. So now we just plug in y2 is negative 1 minus y1 is 5, and then we divide by x2 is 2 minus x1 is negative 1. So next we have negative 1 minus 5 is negative 6, divided by 2 minus negative 1 is 3, and negative 6 divided by 3 is negative 2. So then the next formula I want to use is y equals mx plus b. And we want to know here what is the y-intercept, and the y-intercept is this b value here. So from this step, what I'm going to do is I'm going to plug into this formula. I could plug in either this point or this point. It doesn't matter. We're going to get the same answer. So let's say I plug in x1, y1. I would have y is equal to 5, and I'm setting this equal to m. We just found the slope between the 2 points was -2 times the x value when y is 5 is -1. And then we have plus b. So now I just work this out here. -2 times -1 is +2. And we have plus b. And now I just do -2 on both sides. So 3 is equal to b. That is our y-intercept. Choice 3 is our answer. Okay, but now for the calculator magic, we press stats, we press edit, and I type in the first point, -1, 5. So in L1, I put -1, and then in L2, I put the corresponding y value. And then the other point is 2, and then I have -1 for the y value. Okay, so I'm going to go 2 and then -1. And then all I have to do is press stats, calculate the linear regression. So option 4. This will write the equation of the line for us that passes through those 2 points. Okay, so here's our equation. If A represents the slope and B is the y-intercept, the line would be -2x plus 3. And if I really want to play it safe here, let's say I'm not confident that, oh, this is definitely going to be 3. If I put in -2x plus 3, and then I go to the table, I press second graph, notice the points here. We have -1, 5 shows up, and we have 2, -1 shows up. And this has a slope here of -2 and a y-intercept of 3. So choice 3 is definitely our answer. Question 11, Nancy has just been hired for her first job. Her company gives her 4 choices for how she can collect her annual salary over the first 8 years of employment. Each function below represents the 4 choices she has for her annual salary in thousands of dollars, where T represents the number of years after she is hired. And we want to know which pay plan should Nancy choose in order to have the highest salary in her 8th year. So for this question, what we're going to do is just type all 4 of these into the calculator and see which one has the greatest y value when T is equal to 8. Okay, so the 8th year, we're going to be looking at T equals 8 because they said T represents the number of years after she is hired. Now, if you want to be brave and try to do this first without a calculator, go ahead. But what's jumping out at me with this one is A of T, I'll abbreviate, is an exponential function. This one here is linear. And then this one here is a square root function. Okay, so it has a square root. And then over here, this one is quadratic. So when you're thinking in terms of growth, usually exponential growth is the best, but we are just looking at a short period of time. But over time, exponential always wins. Okay, as long as your base is bigger than 1, the exponential function will eventually win over a linear, a root function, or a quadratic function. Okay, so I'm leaning towards choice 1, but I will use the calculator to be 100% sure. So let's just type these in. We're going to go to y equals, and I have 2, and then the exponent, I hit this up arrow here, and I'm going to put an x, and then I hit the right arrow to get out of the exponent, and then I write my plus 25. And then I go down to y2, and I'm going to type in the linear function, 10x plus 75. It doesn't matter that they're using t and we're using x, because it's just representing the time that goes by. And then square root, I hit second x squared. We have 400t, and then I hit the right arrow to get out, and plus 80. And then for the last one, we have 2 times, in parentheses, I'm going to put x plus 1, close the parentheses and square it, minus 10x, and then plus 50. Okay, so this is going to represent the salaries for Nancy. And now I'm going to press second graph and just get right to the table and looking at t equals 8. So when x is equal to 8, that's really us saying t equals 8. Notice that the first choice here, the exponential function, has the highest value here. So this is the one that we would want. And this is representing the salary in thousands of dollars. So wow, $281,000 a year. That's really impressive compared to these. So yeah, so choice 1 is going to be our answer. Choice 1 corresponds to A of T, and that's the one that Nancy should choose. Question 12, the third term in a sequence is 25, and the fifth term is 625. Which number could be the common ratio of the sequence? So when they use the language common ratio, they're talking about a geometric sequence. It would have been nice if they said geometric sequence just to really seal it, but the word common ratio is the phrase that's giving away that we should be thinking geometric sequence. So the third term, we'll say this is the first term, second term. The third term is 25. And then they tell us that the Fifth term is 625. Well, for one, we have to know the properties of a geometric sequence. If I take an easy one, like let's say this. So this one here is a classic example. When r is equal to 2, the common ratio is 2. That just means to get from one term to the next, I just multiply by 2. So what's happening is we're just multiplying by the same value each time to get from one term to the next. So how do I get from 25 to the next value? I would multiply by whatever r is. But if I multiply by r again, 25r times r would make 25r squared. Okay, so 25 times the common ratio twice is going to bring us to 625. And now I just have to solve this resulting equation here. Divide both sides by 25. And if you do 625 divided by 25, that's 25. And now from here, I take the square root of both sides, and the square root of 25 is 5. So the common ratio for this sequence is going to be choice 2. And we could even see here, if we wanted to double check, if I did 25 times 5, that makes 125. And that would be our fourth term. And if I do 125 times 5, that gives us 625. Okay, so these values here are checking out. Choice 2 is our answer. Question 13, the box plot below summarizes the data for the amount of snowfall in inches during the winter of 2021 for 12 locations in Western New York. What is the interquartile range? So for one, we have to know that the interquartile range is Q3 minus Q1. Okay, so we're doing Q3 minus Q1. And the anatomy of a box and whisker plot. The first value here at the end of this whisker is the minimum value. And then here is the maximum value. And then quartile 1 is the beginning of the box. So here, this would be Q1. Q2 is this line over here, but this is also the median. So the median goes here, and then Q3 goes here, and the max would be the end of quartile 4. But we just label it like this. So when we're looking for the interquartile range, it's just a matter of lining this up on the number line and subtracting those values. So Q3, if I drop this down all the way to the number line, lands at 110. So I would do 110, and then minus Q1, if I drop this down, is going to land on 60. Okay, so Q1 is equal to 60. And if we do 110 minus 60, we're going to get 50. So choice 2 is our answer. Question 14, 4 quadratic functions are represented below, and we want to know which function has the smallest minimum value. So I'm going to start off with the easiest ones first. The easiest minimum value to spot is the one here on the graph, because all I have to look for is the vertex. When you have a quadratic that opens upward like this, the minimum value occurs at the vertex. So here, I just have to identify the coordinates. The coordinates would be 1, negative 4. And the actual value itself, the function value, represents the y value. So the y value here, negative 4, that's our minimum value that we're starting with. So now I look to something like Roman numeral 4. When I have a table, all I have to look for is the vertex, or we could see here the turning point where the values start to repeat. So here I have a minimum value of negative 5, and I know this is the vertex because you see I have y values repeating as I go up from the vertex and down from the vertex. So now we have a minimum value of negative 5, which beats negative 4. Negative 5 is less than negative 4. So now it's down to Roman numerals 1 and 3. So we could go over to the y equals and we'll type in the functions. So I'll type in a of x first. We have parentheses x minus 3 squared, and then we have minus 7. And then for the next function, c of x, I'm typing in x squared plus 6x, and then plus 3. And we press graph, and I think it's obvious here that a of x, which I graphed in blue, has a smaller minimum value than what we have here in red for c of x. If I want to be super precise, I press second graph, and I go to the table, and I'm looking for the turning point here. So I could see that the turning point for the blue table is occurring here. It looks like it's happening at 3, negative 7. And then for the other one, it looks like it's happening here at negative 3, negative 6. So for a of x, once again, the vertex is occurring here at 3, negative 7. So negative 7 would be the minimum value for a of x for Roman numeral 1. And now we have a minimum value that is less than negative 5, so this answer choice is out. And then if we look for c of x, we could see the vertex is occurring over here at x equals negative 3, y equals -6. So -6, this minimum value here, does not beat this one. Okay, -7 is less than -6. So this one is out. So Roman numeral 1 is our answer. Choice 1 we're going to select here. Now, one more thing before I move on is I want to look at the vertex form of a quadratic equation. If I have a times x minus h squared plus k, if I have an equation in this form, this is the vertex form of a quadratic equation where the vertex is the point hk. Okay, so the vertex is hk. So when I have something in this form, I can just say that the vertex of a of x is, and I just identify it quickly, is h is equal to 3 and the k value is -7. Just know this equation is a little tricky to use because it's x minus h squared. So this value here, I have to take the opposite of -3, which is +3. But notice that it's plus k. So for the end, I just take whatever the constant is at the end. And this will also tell me that the minimum value is -7. For finding the minimum value of this one by hand, I would use the formula for the axis of symmetry of a parabola. When I use x equals -b over 2a, that tells me the x value that if I drop down a vertical line, that vertical line will cut the parabola in half nicely. So here, if I look, I have an a value of 1, that's my coefficient of x squared. My b value is 6, that's my coefficient of x, and my c value is 3. If I plug into the formula x equals -b over 2a, I would have -6 over 2 times 1, which gives me -3 when I do -6 divided by 2. Which, if we see here in the table, at x equals -3, that's when this quadratic reached its minimum value. So then all I'd have to do is just plug -3 in, and I'd get y equals -6. But that would be if I want to do all of this by hand, but you do get a calculator, so use the calculator for something like this. Question 15, the equation that represents the sequence given here is, and we have these 4 answer choices to choose from. Well, for one, we have to recognize what type of sequence this is. And this is an arithmetic sequence. If we look, we could see that to get from one value to the next, we're subtracting 3 each time. So the value that you add or subtract each time is the common difference. So here, I would say my common difference is -3. And then if I want a nice formula to use, I have an equals, we have a1 is the first term, plus n minus 1 times the common difference. So here, I could just say a1 is the first term of the sequence. And now I'm ready to just plug in. I could say that a sub n equals a1 is -2, plus, and now I have n minus 1 times the common difference is -3, and I'm just going to put that in parentheses. And now we go looking for our answer. We have to have a leading -2 plus. So these 2 answer choices are out, and the common difference is -3, not +3. So that's why this one's out. Choice 2 is definitely our answer. Question 16, the dot plot below shows the number of goals Jessica scored in each lacrosse game last season. And we want to know which statement about the dot plot is correct. Now, if this dot plot doesn't make a ton of sense, what it's really saying is that in a certain game, Jessica scored 0 goals. And then in another game, she scored 0 goals. And in another game, she scored 0 goals. You can list it out like this, but this could be pretty tedious to do. But for 20 games, that's not the worst list that we'll have to make. But let's say there was like 40 or 50 of these. You probably don't want to list it out like this. But I'll go ahead and list it. So here are the 20 games, and I'm putting it in order from least to greatest. So when we're looking for the mean, median, and mode, I'll find the mode first. The mode we're going to find by just looking for which one shows up most frequently, and that would be 3. Okay, the games where Jessica scored 3 goals, there was the most amount of those games. Okay, that happened 5 times versus second place was 2 goals per game. She had 4 games where she scored 2 goals. Okay, then the next thing that we have to find is the mean. So here, the mean, I'm going to add up all of this and then divide by the total number of games, which is 20. If I had to count how many games there were, I could just see here it's 3, 6, 9, and then that extra one is 10. There's 5 here, so that makes 15, and then there's 5 more, that makes 20. So there were 20 games in total, okay? So 20 games total, and that's going to tell us what to divide by. If you want, I'll show this after, but you can just type all of this into the calculator, and it will give you all of those values all at once. But this is if you want to do things by hand. So for the mean, what I'm going to do is I'm going to say, all right, well, instead of adding all of this up and writing a sum with 20 terms, I'm going to say 0 happened 3 times, plus 1 happened 3 times. And then there were 4 games where Jessica scored 2 goals. So, I mean, I could say 2 times 4, or I could say 4 times 2. It doesn't matter. I'll say 2 times 4, just so that it matches what we have over here. And then there were 5 games where Jessica scored 3 goals. And then there were 2 games where Jessica scored 4 goals. So the 4 goals happened twice. And then there were 2 games where Jessica scored 5 goals. So 5 goals happened twice. And then there was just 1 time that Jessica had a game where she scored 6 goals. And then I divide all of this here by 20. I mean, this I'll just work out because I'm going to show how to do this all in the calculator anyway. So 0 times 3 just cancels. We would have 3 plus 2 times 4 is 8, and then plus 15 plus 8 is 4 times 2, and then 5 times 2 is 10, and then plus 6, and we're dividing all of this by 20. So the mean, now I will start to simplify a little bit more. So this will make 11 plus 15 is 26, 26 plus 8 is 34. I could do 34 plus 6 is 40, and 40 plus 10 is 50, and we're dividing that by 20. So here the zeros just chop. 5 divided by 2 is 2.5. And then the last thing we have to find here is the median, which is the middle value. So for this one, if I didn't feel like listing everything, I would just start Xing off the values going from the beginning and the end and working my way towards the middle. So here I would do 1, 2, 3 off the beginning, and then I would do 1, 2, 3 off the end. And I'm going inward like this. So then I'll do 3 more going towards the middle, and I'll do 3 more. Okay, so now I'm back on the left, and maybe now I'll do 2 at a time. So I'll do 1, 2, and then I'll do 1, 2. And then I'll do 1, 1, and notice that I have an even number left. And when you have an even amount of data, what you have to do is take the average of these two. So the median is actually going to be 2 plus 3 divided by 2, and 5 divided by 2 is 2.5. So notice that the mean and the median match. They're both equal to 2.5. So we can say the mean is equal to the median. Choice 2 is our answer. But if you want to do this all in the calculator, what you could do is just hit Stats, Edit. I'm going to clear out these values from before by pressing Delete. And I just type all of this in. So I press 0, and I'm going to have to type it 3 times. And I'm going to do this for all the other values here. So we have 1 showing up 3 times. And now I'll just type in the rest. And remember, we said there were 20 values here. And notice that my table stops here at 20. So now I go to Stats, Calculate, and these are 1 variable stats that I'm calculating. And I go all the way down to Calculate, and this gives me all the values that I need. I go to the end, and this is once again telling me what I need to know. So I just copy and pasted the entire table here, and we could see that the mean, the X with the bar above it, this is the mean, is 2.5. The median is down here is 2.5. And yeah, that tells us what we need to know. The mode I would just have to look for myself, but that's the easiest thing to spot from the dot plot. But remember, with the calculator or by hand, we're going to get choice 2. Question 17, the students in Mrs. Smith's algebra class were asked to describe the graph of g of x compared to the graph of f of x. And we want to know which student response is correct. Well, if you know your transformation rules, you'll see here that when you take x squared and you replace the x with x minus 3, this sends your graph to the right 3 units. Okay, so I just know that's part of the answer. So we're not going to say shifted left 3 units, we're shifting to the right 3 units. So Ashley and Beth are incorrect here. And then we have to think about what happens when we multiply by a positive constant that is greater than 1. That's going to make the graph more narrow. Okay, so here I could just see right away that choice 4 is going to be our answer, but we do get a calculator. So we can just go over to the y equals, and we could type in x squared. That's our parent function, the function that we're just starting off with, the most basic parabola we have. And now the transformation of x squared that we're going with is 2 times x minus 3, and then that raised to the second power. And now when we press graph, there's the parent function. You could see that the red, we take the blue and go 1, 2, 3 spaces to the right, and you could see that this graph is definitely more narrow than this one. Okay, if we need to zoom in, let's say that's not doing it justice for you, you could press, this is a nice trick, zoom box. And you could go kind of like you're cropping a photo. You go to the top of the window that you want, you press enter, and then you scroll down and you scroll over. And what this will tell the calculator is only to graph this part of the graph. And I think now it's more obvious that the red one is more narrow. And now if you're thinking like, oh no, my window is out of whack, how do I fix it? Just press zoom 6 and that'll put it back to standard mode like this. So the graph confirms what we had. We could say here that g of x is shifting f of x 3 units to the right, and it is narrower. Choice 4 is our answer. Question 18, one Saturday, Dave took a long bike ride. The graph below models his trip, and we want to know what was Dave's average rate of change in miles per hour on this trip. So for this question, we have to know the formula for average rate of change of f of x on the interval AB. Okay, so when we're on this interval AB, how do we find the average rate of change? We use the formula f of b minus f of a over b minus a. This is really just us finding the slope between 2 points, but that's the technical way of writing the formula for average rate of change. So for the trip, we are looking at the beginning and the end. So the beginning here, the point is 0, 0. And the end, we're looking over here. This is occurring. Let's just make sure we line this up nicely. Looks like 5.5. Okay, so 5.5 is the ending x value. And the final y value here is occurring halfway between 50 and 60. So that's happening at 55. Okay, so 5.5 and 55. So now, if you want to think of this as just using the slope formula, you can also just shift and use y2 minus y1 over x2 minus x1. But once again, the fancy textbook definition of average rate of change of f of x on AB is this one here. So we can use this one, but we don't actually have a function name for this, so we can just go ahead and find the slope using the slope formula. So I'll call this one here x1, y1, and I'll call this one over here x2, y2. And now I just find the average rate of change. And I'm going to say here the interval, that this is happening on the interval 0 to 5.5. So now I'm just going to find that slope. I'm doing 55 is y2 minus y1 is 0 over x2 is 5.5 and then minus x1 is 0. And they're telling us the units here are miles per hour, but if we look at the y values, the units for the y are miles. So it's miles, and the x-axis units are hours. So that's where miles per hour is coming from. And now I'm just doing a 55 divided by 5.5. And for this one, we could just use the calculator, but this is going to divide nicely to make 10. Okay, so the average rate of change is equal to 10. If I wanted to say one more thing here, what it really is modeling is the slope of this line that I connect from the beginning to the end. So the slope of this line, that is the average rate of change that we found. The slope of this line here is 10. Question 19, which expression is equivalent to, and we have this expression here. So we're going to use order of operations here. So remember, order of operations, we have PEMDAS. Some people like, please excuse my dear Aunt Sally to remember this. But that tells us to do parentheses, exponents, multiplication, division, then we do addition, subtraction. So the fact that we're multiplying these two binomials and then we have to subtract this one, we're going to multiply first before we subtract. So I'm going to do x times 2x is 2x squared. Then I have x times 7 is 7x. And then I'll distribute the minus 5. So we have minus 5 times 2x is minus 10x. And then minus 5 times 7 is minus 35. But I still have this minus x plus 5 at the end. So now we can combine like terms. We have 7x minus 10x. So I have 2x squared. 7x minus 10x is minus 3x. And then I have minus 35. And then I have minus x plus 5. Now for this part coming up, please be very, very careful. Make sure that you distribute the negative through. The most common mistake that I see with questions like this is that students go 2x squared minus 3x minus 35, and then they go minus x plus 5. And watch what happens. If I do this, I have 2x squared minus 3x minus x is minus 4x. But when I do minus 35 plus 5, I get minus 30. And then I choose something like choice 3. Choice 3 is a very dangerous bear trap, okay? We have to be careful here. That's why we have to remember when we are subtracting a binomial like x plus 5, we have to send the negative through. So we're going to do 2x squared minus 3x minus 35, and we're going to do minus x minus 5, okay? The minus is distributing to both terms here. And now I simplify. I have 2x squared, and then minus 3x minus x makes minus 4x. Just think of this as doing negative 3 minus 1. And then negative 35 minus 5 is going to give us minus 40. So the correct answer here is actually going to be choice 4. Question 20, the functions f of x and g of x are graphed on the set of axes below. And we want to know what is the solution to the equation f of x equals g of x. So for this one, we just have to look for the points of intersection between f of x and g of x. And that's going to tell us where the solutions are. So here, notice that the first point of intersection occurs at x equals 1, and we're going down 1, 2, 3. So 1, negative 3. And then the next one occurs over here at, let's see, 1, 2, 3, 4, 5. So we're going over 5. And we're going up 1, 2, 3, 4, 5. And now we look at the answer choices here. These solutions are always in terms of the x's. What are the x's where these graphs intersect? So we're looking for 1 and 5, and that's going to correspond here to choice 1. Question 21, when babysitting, Nicole charges an hourly rate and an additional charge for gas. She uses the function c of h equals 6h plus 5 to determine how much to charge for babysitting. The constant term of this function represents. So for this one, I always think of the equation y equals mx plus b. Or anytime I'm dealing with a question like this, m is the slope, but in word problems, this is the rate. Okay, so the rate goes here. B is the fixed amount or the initial amount. And then the other values here, x and y. X is usually a time component. Okay, this in the context of this question, we'll say how many hours Nicole works. And y is like the total. So that's how I'm thinking about this just going in. So now I reread this. So Nicole charges an hourly rate. So that's going to be the slope, and the slope here is 6. So the hourly rate is looking like $6 per hour. Okay, they didn't give us an actual unit here for the time, did they? Let's just see if we reread this. Yeah, I guess that's a little bit sloppy. That h, I'm guessing, represents hours. But I want to say for a question like this, they should define h as the number of hours worked. So now we move on and let's see what else we have. So the fixed amount, the additional charge for gas, that's going to be the fixed amount here, and that's going to be the $5. So where this is coming from is, if you think about it, Nicole babysitting, she only has to drive there to do the babysitting and then drive home. So that is the fixed cost. She's just paying for the gas for the drive, and then that's it. That doesn't depend on how many hours she works. That's why that's the fixed amount. And then C of H would represent the total amount of money that she makes. H is the number of hours that she works. So the constant term here, 5, represents the additional charge for gas. The hourly rate Nicole charges, that's the slope. That's the $6. So that's not the answer. The number of hours Nicole babysits is represented by H. And then the total here would be C of H. Okay, so that would be the function value C of H, would be how much money Nicole earns from babysitting for H hours. Okay, so choice 1 is our answer. Question 22, when solved for x in terms of a, the solution to the equation 3x minus 7 equals ax plus 5 is. So these type of questions could be very tricky, but I want to focus first on something easy. So if this were something easy, let's say instead of 3x minus 7 equals ax plus 5, we had something like 3x minus 7 equals, I don't know, let's just say it was 2x plus 5. Well, to solve an equation like this, you would start by doing minus 2x on both sides. So here, I'll rewrite this equation over here. We have 3x minus 7 equals ax plus 5. We treat it exactly the same way as we treat this one. So when we do the easy equations, I'll just make this line a little bit neater. But when we're doing the easy equations, it's the same exact strategy for when we're doing these complicated literal equations. So notice here that the 2x minus 2x cancels, and 3x minus 2x is x, and I get minus 7 equals 5. The problem with literal equations is that when we do minus ax on both sides, these terms don't actually combine to 1. We actually have to leave this for now as 3x minus ax, and then minus 7 equals 5. Okay, but I'll show you in a moment how to deal with this. For the easy, we would just do, plus 7, and then we're done. Okay, so we would have x equals 5 plus 7 is 12. So here I would go plus 7 to get the x terms all by themselves. And now we have 3x minus ax equals 5 plus 7 is 12. The only extra catch here, I'll put a second easy equation over here, is if I had something like, let's say, 4x equals 12. in a situation like this, I would divide both sides, and that would give me x equals 3. So this is like the second easy equation we could deal with. So this is another easy equation. But in this case, what I would have to do, once again, I can't just combine these nicely like we did here doing 3 minus 2. I would have to factor this x out. Okay, so I'm going to factor out the x and write it outside parentheses. So I'm going to have x times 3 minus a equals 12. And you could see here, if I were to use the distributive property and send this through, that would bring me right back to the previous line. I would have x times 3, which is 3x, minus x times a is ax. But now to solve for x, all I have to do is divide by that factor 3 minus a. Okay, so that's what's going on here. And this is kind of like what we do here. We divide by the coefficient of x, except this time our coefficient is represented as a binomial. And now 3 minus a cancels, and this tells us our solution here. We'll just make that a little bit neater. We have x is equal to 12 divided by 3 minus a. And this matches up with choice 2. Question 23, Wade van Niekerk, a runner from South Africa, ran 400 meters in 43.03 seconds to set a world record. Which calculation would determine his average speed in miles per hour? So for this one, I want to look at something easy first. I am 6 feet tall. And that's a true statement. I'm exactly 6 feet tall. And I ask students, how many inches tall am I? And they say, oh yeah, just do times 12, so you're 72 inches tall. But how do the units change from feet to inches? So what's actually happening here is we are multiplying by 12 inches over 1 foot. And the reason we're doing this is 12 inches is equal to 1 foot. So when I have a fraction where my numerator is equal to my denominator, that fraction is equal to 1, except if it's 0 divided by 0, but everything else, it'll equal 1. So if I do 6 feet times 1, I'm still going to get 6 feet. I'm just changing what it looks like. Okay, so that's really all that's going on here. So now notice feet over feet cancels out. The units change to inches, and when I do 6 times 12, I get the 72. So I'm looking for units that are in the numerator and denominator. I want matching units up and down so that they cancel. So right away, I could see 1 is no good because if I do meters times meters, that's going to give us square meters. And that's not what we want. We want miles per hour at the end. We want this to end at miles over hours. And we just make that a little neater. So we have miles over hours like this. That's where we want to land. So now I go to the next answer choice 2, and notice meters over meters cancels. But here's the problem. When I do seconds times seconds, I get seconds squared, or square seconds. So that's no good. So choice 2 is out. For choice 3, we have meters over meters canceling. And then we have seconds over seconds canceling. And notice that we're left with miles per hour. So this one here is looking good. But let's see, why is choice 4 no good? Well, for this one, notice we're doing meters times meters. So right away, we're getting square meters, which is not what we want. We want to end at miles per hour. So choice 3 is definitely our answer. Question 24, which function has a domain of all real numbers and a range greater than or equal to 3? So for this one, we'll just go over to the y equals, and I could type in all of the functions at once, or I could do these one at a time and then just sketch what they look like. So we have negative x plus 3. This is a linear function. So there's the line y equals negative x plus 3. And then we could type in the others. We have x squared plus 3. And then we also have these other two here. Now, one thing I want to point out, this is another calculator trick. If I go to the equal sign and I press enter, the equal sign is no longer highlighted, so that now when I press graph, the function remains saved in the y1 spot, but it just tells the calculator not to graph it. I'm just pointing that out. You may know that feature or you may not, and it is useful at times. And then we have, let's see, for the third one, we have 3 to the x power. And then last, we have the absolute value function. So that's math. We go to the right to number. ABS is absolute value. And then we have x plus 3. So what I'm going to do is I'm going to just take sketches of all of these graphs just one by one. So now we'll just go through these graphs one at a time. So for choice 1, we have the graph of f of x. And the domain is the set of all real numbers because this line goes all the way left and all the way right. So there's no restriction on the x values. And yeah, maybe I should point that out first. The domain is the set of all possible x values, and the range is the set of all possible y values. So choice 1 so far is so good with the domain being all real numbers. But the range here, notice that this graph goes all the way up and it goes all the way down. So the range here for this one would actually be all real numbers. Okay, so the range for the f of x graph would be all real numbers, which would eliminate this answer choice. We want the range to be greater than or equal to 3. So now we look at choice 2. The domain is all real numbers because for a parabola, we could go all the way left and all the way right. We could plug in numbers as big as we want for x, and we could plug in numbers as small as we want for x. And now if we look at the range, the vertex is occurring here at 0, 3. And this is the minimum value here. Notice this is a minimum function value here. So that tells you that all of the y values here for this range, the y values are all greater than or equal to positive 3. So choice 2 is our answer. But let's see, why are the other answer choices no good? The domain for h of x is also all real numbers. It goes all the way left and it goes all the way to the right. But the range, if we look here, that the exponential curve is approaching the x-axis. It's not going to touch the x-axis, but it's getting closer and closer and closer and closer to the x-axis. So this one's a little bit more difficult to say, but the range here is actually the y values are just greater than 0. Okay, so here, all we'd have to do to discount, like, wait a minute, if I look at my table, I'm seeing values here that, are greater than 3. However, for h of x, if you just look at the table for this, let's say you were to plug in x equals 0. If you had 3 to the 0 power, this would equal 1, and there's a y value that is less than 3, not greater than or equal to 3. So this one is out. And now, finally, for choice 4, the domain is all real numbers because the v for the absolute value goes all the way left and all the way to the right. But the range, notice that the minimum value is here at -3, 0. So the minimum value, so the min value is y equals 0. So that would tell us the range here is y is greater than or equal to 0. So that's why 4 is out. Choice 2 is definitely our answer. So now we move on to the part 2 questions here, the free response, and the 6 questions here are worth 2 credits each. Question 25, we want to solve this inequality algebraically. So we could start by distributing the 5 through the parentheses. So we have 5 times x is 5x, and then we have 5 times -2 is -10. And this is less than or equal to 3x plus 20. And now from here, pretend that you're solving an equation. You want to get the x's on one side. So from here, I would do minus 3x on both sides. So we're doing minus 3x on the right side and the left side. 3x minus 3x cancels, and then we have 5x minus 3x is 2x, and I bring down the minus 10. And this is less than or equal to, we're left with 20 on the right side. Now from here, we could just do plus 10 to both sides, and that's going to cancel out the minus 10 on the left. So we'll just make this a little bit neater. So we have minus 10 plus 10 canceling out. And now we have 2x is less than or equal to 30. And from here, we're going to divide both sides by 2. 2 divided by 2 cancels, and we have x is less than or equal to 30 divided by 2 is 15. Now, one thing I want to point out, it didn't happen in this question, but when you multiply or divide an inequality by a negative on both sides, the sign flips. But for this question, we didn't have to worry about that at all. Our solution is x is less than or equal to 15. Question 26, given g of x equals this, we want to evaluate g of -3. So when you're evaluating a function, if you're doing it by hand, what you could do is replace all of the x's with blank parentheses. So I'm going to say blank to the third plus 2 times blank squared and then minus blank. And what we're doing here is we're plugging in -3 to the function. So I'm going to put a -3 here. I'm going to write it here. I'm going to write it here. And I'm going to write it here. And then the rest we could just type in the calculator. So on the main screen, we have -3 in parentheses to the third power. And then we have plus 2 times in parentheses, we have -3 squared. And then we have minus -3. And this is going to simplify to -6. Now, one thing to be careful with here is the most common mistake that I see for questions like this is, let's say you leave the parentheses out. Let's say you just do -3 to the third power, and then you have plus 2 times, let's say you write -3 squared like this, and then we have minus -3. Notice that we get a different answer. Okay, writing this stuff without parentheses is a very dangerous bear trap. The odd power is not a problem here because when you raise -3 to an odd power, it's going to come out negative. it's this term over here. Okay, you have to make sure that you're writing parentheses. The reason being, if you write -3 squared like this with parentheses, the calculator reads this as -3 times -3 is 9. When you write it without parentheses, the calculator reads this as -1 times 3 to the second power, and your answer comes out negative. Okay, so that's why I show parentheses here, and that's exactly how I type it into the calculator. So now we'll just write our final result. G of -3, this whole expression simplifies to -6. Question 27, given the relation r equals, and we have the set of these 4 points, state a value for x that will make this relation a function. And we have to explain why our answer makes this a function. So when you want to turn a relation into a function, the thing you want to look out for is repeating x values. If your x values repeat, then the relation is not a function. If all of your x values are different, that means all of the x values are going to have unique y values, and that will make the relation a function. So we could pick any x we want that isn't -1, 0, or -2. So let's just say we pick out x equals 7. So I'm going to state a value of x. I'm going to say x equals 7. And now why does this answer make the relation a function? Because then all of the x values will have a unique y value. Now, this explanation is valid because it's mentioning how each x is mapping to a single y value. We run into trouble when we have repeating x values because let's say I had x equals 0 over here. Then I would have 0, 3, and 0, 5 on my graph. And if I just do a quick sketch over here, 0, 3, I would put over here, and then 0, 5, I put over here. And notice that if I have these points next to each other on the graph of the relation, if I draw down a vertical line like this, notice the vertical line hits at 2 locations, which if your vertical line hits the graph at 2 locations, then the graph does not represent a function of x. Okay, so that's why here, picking an x value other than one of the ones highlighted here is going to be sufficient for question 27. Question 28, a survey of 150 students was taken. It was determined that 2/3 of the students play video games. Of the students that play video games, 85 also use social media. Of the students that do not play video games, 20% do not use social media. And we need to complete the two-way frequency table. So for questions like this, I like to go piece by piece and then reread to help fill out the other pieces. So here, the most obvious information they gave us is that there is a survey of 150 students that was taken. So this represents the total, okay? The total amount of students is 150, okay? So that's all of the students in the survey. And then they told us that 2/3 of the students play video games. So I'm just gonna take 150 and I'm gonna multiply it by 2/3. So this is for the number of students that play video games, okay? So for video games, this is going over here. And if I work this out, I'm going to do 150 divided by 3 is 50, and 50 times 2 is 100. So the total number of people that play video games is 100. And now from here, to find out how many people do not play video games, we have to add up to 150 here. So we could just do 150 minus 100. Let me just make that neater. So 150 minus 100 is 50. And that value is going here. So once I have 2 entries in a row or column, I just do the math to find the third. So that takes care of video games. Of the students that play video games, 85 also use social media. So let's think about that. The number of students that play video games and also use social media is 85. So that's going to go here. And now notice we have 2 entries and there's a third one here, but 85 plus the number of people that don't use social media has to make 100. So I could do 100 minus 85, and that's equal to 15. Okay, so 15 is going to go here. And now next we have of the students that do not play video games, so that's here, 20% do not use social media. So over here, there are 50 students that do not play video games. 20% of them do not use social media. So now I'm just going to take 20% of 50. Okay, so 20% of 50. For this, there's a few ways we could do it, but I could just write 20% as 20 over 100. Of means multiply, and then 50 I write here. And now I could just cross off a common 0. I could say 20 divided by 10 is 2. So now I just have 2 times 5 is equal to 10. Okay, so 20% of 50 is equal to 10. And that's going under the entry for people that do not use social media, that do not play video games. Okay, so no social media, the 10 is going to go here. But then how many have to go here? Well, blank plus 10 is 50. I could just do 50 minus 10, and this is equal to 40. You are only being graded really on the completion of your table. It's not saying justify. So, I mean, I still show the work off to the side, but I'm not going to go too crazy labeling everything. So now I have that this is 40. And now for these totals, I just have to add. So we're just going to do 85 plus 40. And that's going to give us, we're going to have 125. So 125 is going here. And now for this one, 15 plus 10 is equal to 25. And one thing I would double check is that when I add these up, 125 plus 25 is 150. So these values here are looking good. Question 29, we're going to use the method of completing the square to determine the exact values of x for the equation given here. So when I'm using completing the square for an equation like this, I like to get the x squared and x term alone. So I'm going to move the minus 30 over to the right side. So I'm doing plus 30 on both sides. And now we have x squared plus 10x. The minus 30 plus 30 cancel out. And I'm going to leave a space here. And this is now equal to 0 plus 30 is 30. So the technique of completing the square, if you just want to have a method to have memorized, is you're going to look at the quadratic part on the left. And in this case here, we have x squared plus 10x. But in general, you're going to have something like x squared plus bx. And what you're going to do is you're going to take half of the b term, you're going to square it, and you're going to add that number to both sides. Okay, so that's where my head goes next. So what I'm thinking of is okay, the b term here is 10. I'm taking half of that and squaring it. So if I do half of 10, that's equal to 5, and 5 squared is equal to 25. And that is the mystery value that we're going to add to both sides of this equation. So I'm going to do plus 25 on the left side, and I'm going to do plus 25 on the right side. Now, the reason we call this completing the square is now, if we did this correctly, it turns the left side into a perfect square trinomial. And what that means is that when we factor this, our factors should be identical. Because if you think about it, a nice perfect square, like let's say 49, is equal to 7 times 7. And this is a number that could be expressed as the product of two matching factors. That's what makes 49 a perfect square. So here, think about it. What two numbers have a sum of 10 and a product of 25? Well, 5 plus 5 is 10, and 5 times 5 is 25. So we could write the left side as x plus 5 times x plus 5. So here is the matching factors that turns this into a perfect square trinomial. Okay, and on the right side, 30 plus 25 is 55. And now the left side, x plus 5 times x plus 5, we could express as x plus 5 squared. And this is now equal to 55. And from here, to get rid of the square, we're going to take the square root of both sides. But one thing we have to be very, 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 very careful of is we can't just say the square root of x plus 5 squared is x plus 5. We have to make sure that we tack on the plus or minus. Okay, so this is a common mistake with students is they forget to write plus or minus next to the square root. So we have plus or minus the square root of 55. And now the last step here to solve is we're going to do minus 5 on both sides. And the way that we express our answer, we're going to say x equals negative 5 plus or minus the square root of 55. If expressing your answer like this is confusing, just know the concept of what's actually happening here is we have two answers. Okay, our first answer we could say is negative 5 plus the square root of 55. And our second answer is negative 5 minus square root of 55. Okay, so that's what plus or minus means. It means you have two answers. So we could say plus this value or minus this value. Another thing we could do here to be safe is we could type in our answer. Let's say I type in one of the answers, negative 5 plus the square root of 55. So I type this in, I press enter. Now I'm going to press store, and I'm going to store this. I'm going to press alpha math to bring up the letter A. And that's going to store that number as the letter A so that every time I press alpha math, it's going to write in this infinite decimal here, this irrational number. So now I'm going to go back to the original equation here and watch what happens if I do, instead of x squared, I do the answer squared, and then I do plus 10 times the answer, and then I do minus 30. I should get 0 if we solve this correctly, and we do get 0. And then one more thing we could do to verify is we could just switch that plus to a minus and check the second answer as well. But I promise if we store this and plug in, we're also going to get 0. So these two solutions here are good. Question 30, we want to factor this expression completely. And the first thing I look for when I have to factor completely is the greatest common factor. So looking at 20 and 45 first, the greatest common factor of those two numbers is 5. And then for x to the third and x to the first, the greatest common factor is x to the first power. And then next, we're just going to write the leftovers inside the parentheses here. And my thought process, the math that I'm doing in my head, is I'm dividing the original expression by the greatest common factor. So I'm doing 20x to the third minus 45x. I'm dividing both of these by 5x. And the results are going inside the parentheses. So 20 divided by 5 is 4. And when I do x to the third divided by x to the first, I'm doing x to the 3 minus 1 is x to the second power. And now we have a minus connecting these, and 45 divided by 5 is 9. And then x over x just cancels, so we're left with just 9 here. So I'm just going to move this parenthesis a little bit closer. All right. From here, now I want to use a difference of two squares factoring technique. So for this, what we have is something in the form of a squared minus b squared. So this factors nicely to a plus b times a minus b. And the thought process for this part of the question is to go from here to here. I'm taking the square root. Okay, so I'm doing the square root of the first term plus or minus the square root of the second term. Okay, so we're just taking the square root of the first and second term here. So now I'm going to say next, this is equal to 5x times, and now I have two blank parentheses here. And I'll just move this part here out of the way. So now we're going to do the square root of 4x squared. We're going to say is 2x. And now I write my plus or minus inside the parentheses, and the square root of 9 is 3. And this is our solution to question 30. So now we're moving on to the part 3 questions. There's 4 questions in this part, and each one is worth 4 credits. Question 31, we're going to graph the following system of equations on the set of axes below, and then we're going to state the coordinates of all solutions. So for this question, we're just going to go over to the y equals, and we could just type in the two equations here and see what we get on the graph. So we have for y1, we're going to write x squared, and then minus 3x, and then minus 6. And for the second equation, we have x minus 1. So we press graph here just to get an idea of what this looks like. It looks like we have two solutions because we have 2 points of intersection. So we have the graph, but what's also really important here is going to be the table of values. This is going to help us stay accurate when we actually graph this on the set of axes below. So now that we have both equations graphed here, we have to look for the points of intersection, which are occurring here and here, and identify the coordinates. So we have the first point of intersection is at -1, -2. So there's the first solution is over here, and the second solution is occurring at, let's see, 1, 2, 3, 4, 5. So x equals 5, and then y is 1, 2, 3, 4. So at 5, 4. And if we look at the table here, we could see at -1, the y values both match. So this is looking good over here. Just highlight this. So at -1, x equals -1, we have matching y values. And when x is equal to 5, the y values match here as well. So when we actually write out this solution, they're asking us to state the coordinates. So I'm just going to say here -1, -2, and we have 5, 4. So here are the solutions to this system. Question 32, the table below shows the amount of money a popular movie earned in millions of dollars during its first 6 weeks in theaters. And the first thing we want to do is write the linear regression equation for this data set, rounding all values to the nearest hundredth. So we're just going to go to stats and then edit, and we're going to type in the weeks under the X column here in L1. So I'm just going to go up to L1 and press delete, and that's going to get rid of everything that was typed a moment ago. If you're like, oh no, it says L2 and L3 now, you could always just reset the calculator, press second memory 712, and notice now when I go to stats, edit, that everything is waiting here. Now, one thing to point out for the correlation coefficient that we're going to need in a moment is we're going to have to go over to mode and turn stats diagnostics on. Okay, so I'm going to have to go here and turn this on. Another way to turn this on, if your calculator doesn't have this option here for the TI, is you could hit second 0 and go to the catalog. You could scroll down to the letter D for diagnostic, or you could press alpha x -1. I do that twice, and you see how it skips all the way down to the letter D, and then diagnostic off, diagnostic on. You could do it here as well and just turn it on like this. So now I go to stats edit, and notice my table is blank. So I just type in my X values here. So I have 1, 2, 3, 4, 5, 6. And then for the Y values, these are going to go in the L2 column. So we have 185, we have 150, and we just press enter after each entry. And we just type this in all the way down to the last one. And from here, I'm going to hit stats, calculate, linear regression is option 4. And we calculate, and this gives us all the values we need. So the first thing we're going to do is write the linear regression equation, and we're rounding to the nearest hundredth. So here, I'm just going to write out we have y equals, and our a value here in front of the x term here is going to be -37.57, because notice at the 100th spot we have a 7, to the right is a 1, so we're rounding down. And our b value here is equal to 215 and we're going to round this one to 67, because in the 100th spot we have a 6, to the right is a 6, so we're rounding up to 67. So here, I'm just going to say y equals ax plus b. You don't have to show this step. You can just write the answer out. But since I defined a and b, I just want to show how these fit in the equation over here. So now I just make the substitution. We're going to have -37.57 times x, and then plus 215.67. So here is our equation for the first part. For the second part, we just have to state the correlation coefficient to the nearest hundredth. So here, the correlation coefficient is the R value. And if we're rounding to the nearest hundredth, the hundredths place we have an 8, and to the right is a 4. So we're going to round down to -0.98. So here is our correlation coefficient. So now for the last part, we have to state what the correlation coefficient indicates about the linear fit of the data. Well, my thought process for questions like this is the correlation coefficient falls between -1 and +1. And if the correlation coefficient is close to -1 or +1, that makes it strong. As it gets closer to 0, the correlation becomes weaker. And when it gets basically at 0, there's no correlation. So that's what I'm thinking going into this. So R equals -0.98 places the correlation coefficient here. So this is going to be a strong negative correlation. And what happens is, as we get closer to -1 or +1, that just says that in the context of the situation, that a line of best fit, that this line is a good representation of the data in the table. That if we were to plug in these x values here, we're going to get values really, really, really close to the ones here. And it'll be a pretty nice indicator of what would happen, at 7, 8 weeks and so on. So we could just say here that this is a strong negative correlation coefficient, and the linear regression equation is a good fit for the data. Question 33, use the quadratic formula to solve the equation 3x squared minus 10x plus 5 equals 0 and express the answer in simplest radical form. So for one, the quadratic formula we could grab from the reference page, and it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And the a value in this quadratic equation, the coefficient of x squared is equal to 3. The b value is equal to -10, and the c value is equal to 5. So now all we have to do is just plug into this formula. So we have x equals, And b is negative, so we're going to have negative 10. And then we have plus or minus the square root of, and remember, the parentheses are very important. When you plug in negative 10 and square it, make sure you write parentheses, because once again, this is the most common mistake when students are evaluating values for expressions or functions, is leaving out the parentheses. So now we have minus 4 times a is equal to 3 and c is equal to 5. And this is all under the square root here. And then this is all being divided by 2 times a. So now we just simplify, and for this we could use a calculator. So we have 10 plus or minus. If you want to type this entire part here in the calculator, you can. Otherwise, you could do it by hand and then check with the calculator. But this is going to give us 100, and then minus, we're going to have 12 times 5 is 60. So 100 minus 60 is equal to 40. All right, but I'll just write it out here step by step. We have 100. And then minus 12 times 5 is 60. If you want to jump right to the 40 step, you can, but I'm just going to show this piece by piece. And then we have 2 times 3 is equal to 6. So now from here, what we could say is we could say that x is equal to 10 plus or minus the square root of 40 over 6. Now, when they said express your answer in simplest radical form, they kind of gave it away that we're going to have to simplify a radical at some point. So for this part, I would write 10 plus or minus the square root of 40. I'm going to write as the square root of 4 times the square root of 10, because when I'm simplifying radicals, I want to deal with perfect squares. I wouldn't write 8 and 5 because 8 and 5 are not perfect squares. I want the biggest perfect square factor of the number. And now this is all over 6. So now from here, we just simplify more. This is x equals, we have 10 plus or minus. The square root of 4 is 2, and then we have square root of 10 over 6. And now I'm going to break this up into 2 separate parts here. We could say that this is equal to 10 over 6 plus or minus 2 square root of 10 over 6. And for the final part here, I'm just going to simplify these fractions. We have x equals, if we divide the top and bottom by 2, we get 5/3 plus or minus, and then we have 2 over 6 reduces to 1/3. So we get square root of 10 over 3. Okay, so for this part, just break it up into pieces here, and we could write our answer like this. Question 34, we want to graph the system of inequalities on the set of axes below, and then we're going to state the coordinates of a point in the solution to the system, and we have to justify our answer. So for this question, what I'm thinking of is getting these inequalities in the form of y equals mx plus b. Because once you have these in the form mx plus b, you could identify the slope, and you could identify the y-intercept. Once you know the slope tells you the rise over the run. So that's the concept I want to use here, is rise over run. And the y-intercept is telling you where your inequalities sketch is going to begin. Okay, or technically we're graphing here, so we have to be accurate. So the first one is very much more complicated than the second one. There's more algebra that we have to do here, and we're going to be dealing with fractions. So for this one, if I write it off to the side, we have 3y plus 2x is less than or equal to 15. I'm going to start this by doing minus 2x on both sides. My goal is to get y by itself. I want it in the form of mx plus b. So this part cancels. I have 3y is now less than or equal to negative 2x plus 15. And now I'm dividing everything by 3. Okay, so everything here gets divided by 3. So my first inequality rearranged is going to be negative 2/3 x, and then plus 15 divided by 3 is 5. So I could start graphing this by using the y-intercept. I like to think of it as the b value tells you where to begin. So we begin on the y-axis at 5. We're going 1, 2, 3, 4, 5. So we're starting here, and now the slope is negative 2/3. This tells you how much to rise and run. So I'm going to rise negative 2. That means go down 2. And then run 3 means go to the right 3. So I'm going down 1, 2 and over 1, 2, 3. And I just do this until I have plenty of points here to see that I'm forming a straight line. Okay. And I'm going to also go the opposite way. Instead of going down 2 to the right 3, I could go up 2 to the left 3. And I know I'm doing this right if the line is continuing. Okay. So up 2 to the left 3 like this. And now I'm going to connect these points with a straight line. You could bring a straight edge, ruler to the test. You could use a student ID. So I just do this. I make it a solid line because it's equal to. And now I'm going to shade under. Okay, so I'm just going to shade here under the graph. So this, I just sketched or graphed the solution for the first linear inequality. For the second inequality, this one is a little bit easier to simplify. We just have to do plus x to both sides. So I'm going to go plus x on the left and the right side. And now I have y is greater than x plus 1. So for this one, the y-intercept is 1. So we're going to begin at 1. And our slope, the number in front of x, is 1. So a slope of 1 means we're going to go rise 1, run 1. Okay, so we're going up 1 over 1 like this. If you want to type this in the calculator and just copy the points from the table, but then connect them with the dotted line, you could also do that. But I personally like to use the rise over run method for this question here. Okay, so I'm just going to go backwards now by going down 1 to the left 1, and I'm keeping this straight line here like this. So once I get plenty of points here, this one we have to be very careful. It's just greater than, so I'm going to connect these with a dotted line. Okay, so I'm going to go with a dotted line like this. And at the end of the dotted line, I'm going to put an arrow. So I'm just going to put an arrow here like this. And we have to just think here, it's y is greater than x plus 1. So now we're going to be shading above the line like this. Okay, so here is the solution for the second linear inequality. So we're shading above like this. But now we have to identify a point that is in the solution to this system. So the solution to the system is where the solutions overlap. So that's going to be in this space over here. So I'm just going to label this here with an S. And this is just going to represent our solution set. One thing I want to point out, it takes just a quick second, but I would label these inequalities. You see the one that I graphed first here, the one that was downward sloping, that was originally the 3y plus 2x is less than or equal to 15 inequality. I only have to label one of these, but if you want, you can label the second one over here by calling it y minus x is greater than 1. So now that I have everything labeled, I'm just going to go ahead and find a point that is a solution to the system. So let's say I pick out a random point like this one over here. I'm just going to identify the coordinates. This is negative 1, 2, 3, 4, 5, and then 1, 2, 3. So the point negative 5, 3 is a solution to the system. How do we justify our answer? We could say that this point lies in the solution set of the system of linear inequalities. Or if we wanted to, we could plug this x and y into both inequalities and show that it checks out. So this explanation here would get us full credit. If you really want to play it safe here, you could even check your work off to the side, and you could plug in the point negative 5, 3 to both of these linear inequalities here. So if I plug into the 3y plus 2x less than or equal to 15, 1, I have 3 times the y here is 3, plus 2 times the x is negative 5, and let's see, is this less than or equal to 15? Well, here I would get 9 minus 10, and 9 minus 10 is negative 1, and negative 1 is definitely less than or equal to 15, so this one checks out. If I plug in negative 5, 3 to the second inequality, I would have the y is 3 minus the x is equal to negative 5. And is this greater than 1? Well, 3 minus negative 5 is 8, and 8 is greater than 1. That is true. So we could also just plug into both and say the point satisfies both linear inequalities. But we could also just say that it lies in the solution set. So now we move on to part 4, the final question. And this question here is worth 6 credits. So for this question, there's a lot to do. But first, we have Courtney went to a coffee shop to purchase lattes and donuts for her friends. One day, she spent a total of $15.50 on 4 lattes and 2 donuts. The next day, she spent a total of $18.10 on 3 lattes and 5 donuts. All prices include tax. If X represents the cost of 1 latte and Y represents the cost of 1 donut, write a system of equations that can be used to model this situation. So here, let's just see. 4 lattes. Lattes are represented by X. So 4 lattes, I'm just seeing here 4X. And 2 donuts, Y represents the cost of a donut. So we'd have 2 times Y. And this is equal to the total bill was $15.50. So 15.50. And then the next day, she spent $18.10. So that's going to be equal to $18.10 on the second day. And that was 3 lattes. Remember, lattes are X. So 3 lattes is 3X. Plus the 5 donuts. So that's 5 times y. So here is the system of equations that models the situation. But next we have Courtney thinks that 1 latte costs $2.75 and 1 donut costs $2.25. Is Courtney correct? We have to justify our answer. Courtney would be correct if x equals 275 and y equals 225 satisfies both of these equations. Okay, but if it doesn't satisfy one of the equations, then Courtney is automatically incorrect. So we could just plug these values here in and see. So we have 4 times x, and Courtney is claiming that x is 275 or 2.75. And then plus 2 times the y value that she's claiming is 225. So 2.25. And if we look here, it works out to 1550. That's usually the case. They usually make the point satisfy the first equation, but not the second. But we only have to show that it doesn't satisfy one of them. If you write all of this, that's fine, but you only have to write where it does not satisfy. So now let's see. 3 times x is 275. And then plus 5 times y is 225. So 2.25. And let's see what this works out to. This works out to 19.50, which does not match the 1810. So the second equation is the one we're going to use to say that Courtney is incorrect because these values do not satisfy the second equation. So for this part here, we're just going to show that the second equation does not hold true. So we're going to have here 3 times 275 plus 5 times 2.25 is equal to 19.50. And I'm just going to comment here that this is not equal to 18.10. Okay, so this second equation here is not true. So is Courtney correct? We're going to say here no, or I could say Courtney is incorrect. The reason being is that these values do not satisfy the second equation. Now, when they tell you to justify, that just means show work. So we probably could just get away with saying Courtney is incorrect and just leaving it there because we're showing why Courtney is incorrect. So now for the last part, we're going to use our equations to determine algebraically the exact cost of 1 latte and the exact cost of 1 donut. So I'll write down our system from before. We had 4x plus 2y equals 1550, so 15.50. And then we had 3x plus 5y equals 1810. Okay, so 18.10. And what we want to do here is eliminate either x or y. Let's say we want to eliminate y. Then our goal should be to turn the coefficients into matching opposites. So what I mean by that is, let's say I multiply this first equation by 5. I'm going to have 5 times 4x is 20x. And then I'm going to have plus 5 times 2y is 10y. And then equals, if I use a calculator here, 5 times 15.50 is 77.50. But my goal is to get the term underneath 10y to be a matching opposite. So I would want the bottom here to say minus 10y. So how could I do that? Well, I could multiply the second equation by negative 2. Okay, because if I do negative 2 times 5y, that's going to make minus 10y. So now I have minus 2 times 3x is minus 6x. And then negative 2 times 18.10 is equal to negative 36 and then 0.20. One other thing I want to point out is when you want to show you're multiplying both sides of an equation by the same number, you can put parentheses around the entire equation and put the number outside like this. Okay, so this is just a neat way to show that. So now 20x minus 6x is 14x, and 10y minus 10y cancels, and this is equal to, I'll just do the subtraction. We have 0 minus 0 is 0, 5 minus 2 is 3, and then I have 7 minus 6 is 1, and 7 minus 3 is 4. So then from here, I just divide both sides by 14, and for this part, we could use a calculator, but it's just simple division, so this I won't show on the calculator display. If we divide these two numbers, we're going to get 2.95. But now, they want us to find the cost of 1 latte and 1 donut. We just found the cost of the latte because the latte was represented by x. To find the cost of the donut, what we could do is we could plug into any one of the original equations here. So let's say I plug into the first one. So I'm going to focus now on this piece over here. So I'm going to plug into this one. So I'll have 4 times 2.95. So I'm doing 4 times x, which we just found, plus 2 times y is equal to 15.50. And now from here, I'm just going to work everything out. So 4 times 2.95, just type that in a calculator. You're going to get 11.80. And then we have plus 2y, and this is equal to 15.50. And now we just do the subtraction. We'll do minus 11.80 on both sides. And for this part here, these terms will cancel. We'll have 2y is equal to 3.70. So then all we have to do here is divide both sides by 2. And this tells us that y is equal to 1.85. So now our final answer, we technically could stop here, but I'll just write it out formally. We'll say that a latte costs $2.95. So that's for the latte. And then the donut is going to cost $1.85. Okay, so the donut is $1.85. So here are the prices that we were looking for.